Hey guys, welcome back to my channel Learn with PR. So here we started already our C programming and data structures, right? Where I explain concept in a simple step-by-step and beginner-friendly way. I have already published on important topics like basic data types, operators, decision control statements, looping concept, array and its operations. So I recommend you to watch those videos for better understanding. So if you are a student preparing for exam, interviews, or just any exam, or maybe you are doing any kind of starting programming, so this channel will help you build strong fundamentals. So do like the video, share it with your friends, subscribe to my channel, Learn with PR, and if any doubt you have, write in the chat box. So in today's video, we'll discuss about binary search. So let's get started. So searching means finding something. All right. So when you want to find something that you can say searching you are doing. Okay. So I must say that binary search is the fundamental of fast searching algorithm. Why it is? Basically, when you want to search some element in an array, that time you should know that your array should be sort array, right? If it is in ascending or descending form, that time you can apply binary search. Okay, so in linear, we don't basically look for that kind of array, right? But in binary search, this is a fundamental, you can say the condition, right? That binary search works only on the sorted array. All right, so it will be ascending or descending form, that will be more okay. All right. So when you do that thing, when you want to find the element from an sorted array, that time by dividing basically the array into two halves. You have to do it until unless you are finding your particular element, or you can say key you want to search, whatever, so whatever the element you want to search. Okay. So instead of searching, instead of checking all elements one by one, right? In binary search, it reduces the basically search space by half each time, you can say. All right, so that means what? Binary search is faster than linear search because it eliminates half of the elements in every step means whenever you want to find some kind of element, you will go to check the middle first, right? When you are checking for the middle first, and then you have to check that element present in your right half or a second half of your array. All right, that time again you have to shift to the particular half, right? Once you are going for a particular half, you have to check again the middle element and will find out find out your search element, like that way. So basically linear search works like searching a word. Actually, you are searching a word in a dictionary, suppose. Okay, so we don't start no from the first page, we open the middle page and then decide where to go, left or right, right? So that's your binary search. Whenever you are searching a word है ना, dictionary से आप search कर रहे हो एक word को, then you are not going from the A letter ना, not going, because you know कि if the letter is from A, then you will search from starting. But the thing is, when you have any middle element, right, then you will just open your dictionary, right? Dictionary, when you open है ना, then you start कि that word will be in a left side or a right side, like that way, right? That thing, exactly same thing we are doing in a binary search, right? So first of all, you should know that it uses basically divide and conquer technique, right? It's faster than your linear search, commonly used in a data structure, right? So the basic important condition is your the array should be sorted, right? So next, I have given example here. Here example says what? That when you have a array name as what? That you have array name as 10, array name is A, suppose. Okay, and elements are what? 10, 20, 30, 40, 50 and 60. All right, and these are the index values. So our array start from 0 index, you know very well, right? So 0 index we have done, 1 index it is second, third, fourth, fifth and sixth. That means you have 7 elements. It is starting index from 0 to n minus 1, 7 minus 1, that means 6. Okay, these elements we have. Okay, when we are doing linear search, right, that time we do not check that elements are in a ascending order or a descending order, right? That we can do from one by one. So I have already published that linear search video, right? You can check it. And if you have any kind of query, you can ask. Okay, so why it is differ with your linear search, you know, so you will get that thing, you will have a clear picture of it why it is differ. Okay, so now if I'm saying element to search, if I want to search element 60 here, suppose, okay, so what my binary search do? So first step is what, that first you have to say what is low and what is high. What is low, that you know, I think lower bound and upper bound. Okay, so this, what is the lower bound for this array? So this is lower bound, that is 0. Okay, the upper bound you can say 6. Okay, so that's your first, you can simply say from where it start and where it ends. So first is start is your 0 and end is your 6, you can say like that way. Okay, so first thing you should know what low is right now 0 and 6 is right now, sorry, high is 6 actually. Okay, so this is how we can, so how we can do it. When we want to divide it, then what we do, we divide by 2 now. So we do the same thing here, we will do here same thing. So what, low, middle value I want to find first, right? Middle index I want to find. So middle index, how we can find out? So we will do what, low plus high divide by 2. Okay, so that's what exactly we are doing here, that we are doing 6 plus 0 plus 6 divided by 2, we will get 3. Okay, so that means you are saying mid is 3. What does mid means? You are getting the middle index. So when you are getting the middle index, can we say ki middle value we got? Yes, obviously, right? So what we can do, we can, if the array name is A, right, we'll say A of mid. What is A of mid? That means A of 3. You are talking about A of 3. What is A of 3? That is your 40. Okay, so you are saying a mid value is 40, but we are not looking for 40, we are looking for 60 actually, but in middle we are getting what, that 40. Okay, so what we can search, we can say what, if your key, if your key is greater than your 40, so 60 is greater than 40, yes, obviously, then you have to decide where to go, left or right. Okay, so where we have to go, we have to go in the right half actually. Okay, yes, we have to go for to search in a right half. As we know, our array is in the form of ascending, right? That time we will go in the right half. Okay, suppose we want to search 20. So for that, 60 is, 20 is not greater than 40, right? So we will go in the left half, you can say. Okay, so but here we will go in a second half. Once we are going, right half, you can say. So we are going in a right half when, right? Then again we have to check 60 in which index. All right, step 2 is what? Now when you are saying ki we have to go here, okay, so you will see this is now become another array, you can say. You have divided your array in two parts now. So this is the first array, you can say, and now this is a second array, you can say. From 50 say, okay. So we will say this is a second array. Okay, so now here also we have a lower bound and upper bound, means we have to start from somewhere and we have to end from somewhere. So we are starting from 4 here. So now here low become 4, right, and high becomes 6. So once it's becoming, and then you have to find out the midterm again, right? You are doing middle, right? Middle, 4 plus 6 divided by 2, you will get 5. So 5 is the index which we'll say is a middle element. Now this is a new middle element for this array only, for this these elements only. All right, right half. Okay, so now you are saying a5, a5. What is a5? What is a mid? A5, right? Right? So what is a5? That's 60, you can say. So 60 is equal to a 60. Yes. Now you found the element at index. At index, you can say which one? Fifth location. But the position from starting, first position, second position, third position, then you will say I plus 1. Index plus 1, you can say that's 6. Okay, so this is, I have written here, element found at position 6. When you want to find the index value, that time you don't need to write 6 index plus 1. No, you can write simple index, that's a index value. Okay, so you can say like that way if you want to write in this kind of result. Okay, so this is what, this is us this is what binary search. Okay, so binary search do, it divides your array in two halves until unless you are getting the element. Okay, which element, whatever the element you want to find. Okay, so I hope this example, you got this example. From this example, you know how we are doing it. Okay, now this is a simple thing that we had discussed already, how binary search works basically. So we have to, if we want to find the middle element, right, then we have to compare middle element with the search element. Sorry, we have to find the middle element. Suppose first we are finding middle element, and then we are comparing middle element with a search value, whatever the search value we want to find. That was 60. Okay, 60 and the middle value of 40. So if the both are equal, then just write down a found element, obviously, right? If the search value is smaller, then we have to go to the left half, and if the search value is greater, then we have to go to the right half, obviously. Then we have to repeat until the element found, or you can say that element is not present in the array. Okay, if the element is not present in the array, then it will go not means it will go to search again, it will go at the last element. Okay, so yes, we can do like that way also. All right, so this is a simple one, that how we can say that how binary search works. Okay, I hope you got this concept. Let's write a simple program for it. Okay, so I am creating an array. Okay, first I am creating a number of elements. So I am just simply writing printf, enter number of elements, enter number of elements. Okay, when you are writing a number of elements, it will store, obviously, right? So how we can declare array, how we can write the elements inside it, we have already discussed that part. Okay, so you can also check the previous videos of mine. All right. Okay, so now, so once I have decided the number of elements, then I will write a array name. Okay, and I'm writing inside it n. Okay, now we can ask the number of elements. So I'm writing printf. Okay, enter now values. Okay, now scan. So for loop we have to write. Okay, now int I am writing n equals to 0. I will go till n. I will increase one by one. Okay, right, and we will do scanf. It will just provide me the elements here, right, inside my inside my array. All right, and it will go index value from 0 to n. Okay, once I got the elements, then I will ask simply what is the element you want to search, which element you want to search. So I am first declaring key. Key means what? That I want to search what. Okay, I want I want what? Key first. Okay, I'm writing key. Okay, now just say what is the value of key. So enter the value, enter the element you want to search. Suppose element you you want to search. All right, so once you will say I want to search whatever, it will be storing in a key. So I will write like that way. Okay, so once you are getting key, then you have to say what? You have to say int. So we were writing what? Index, lower bound, upper bound we were writing, right? So I'm writing here first or second, or you can writing what? You can start, you can say start will be from 0. Okay, and end will be from n minus 1. So whatever the n value you have written, okay, we don't need to take care of. So n minus 1 I will write simply. Now I want mid also. So when I want mid, that time what I will do, I will simply define here. Okay, so now tell me how we can say that we have to go from array one by one. So for that condition, we don't know how many times I will index will, how many times we have to check for the element. Okay, so we don't know that thing. That's why we are writing while loop. We will not write here for loop. For loop mein to we know na iteration how many times we have to go. But here we don't know if the element present or not. How many times we will go. Okay, so if your start is smaller than and equal to your end, okay, so that time only we have to go inside. But right now we don't know anything, how much, how many times we have to go, how many comparison we have to make, right? We don't know that thing. So first I must say that we have to divide our array. Okay, so how we can divide our array? So mid, I said mid, right? We will have here start plus end, okay? And we'll divide by 2. That's how we can do it, all right? Now we have to check the condition. If A, array name, okay, A, I, if it is equal to mid, okay, if it is equal to mid, that means what? You are finding middle element. So I will write here printf, okay? And we'll write what? Element found at index, or you can say position, whatever, but I am writing index value. So index value I have stored in I, all right? And then break, I will write break here, okay? If I'll get the element, then only, all right? If I'll get the element, then only it will break out. But if it is not finding any element, then it will say what? It will say we have to again start searching. So I am writing else if the element is not middle, which we were looking for, okay? So that time we have to make a one more condition here. That condition should be what? If your A of I, sorry, not mid, we have to write here key, okay? So I have stored it in a key actually. So if your key I have stored, okay, here. So mid is a just a index value you are saying. Here we have to write here A of mid, okay? All right. Now here we have to do what? If your key is greater than your A of mid, okay? If your key is greater than of your mid, then where we have to go? 60 is greater than your 40, no? So where we have to go in the right side. So what we have to change? We have to change start. So start will be mid plus 1, mid plus 1, okay? And end will be same. End will be same, okay? But if this is also not true, then we have to go left side. Yes, we have to go left side. For else I am writing, okay? For a left side I am writing else. So there you will see, if I want to find in the left side, okay, that time start will be 0 obviously, but our end will become mid minus 1, okay? Right? If if start is smaller than end, then it will divide my mid, okay? Once I will get mid, okay, then I will say A of mid is equal to your key or not. If it is okay, if it is you are searching 40 element only, right? So it will simply write yes, it is basically middle value, okay? So it will say what element found in the index, and then break out, it will jump out from that loop. But if it is not, okay, then you have to say 60. Maybe you are finding 60 is greater than your A of mid. Yes, it will say start now become mid plus 1. If you are finding 20, so 20 in a left side now, so you will say end we have to change, and then we will get end again. We have to say we have to again check the condition. If it is true, then it will again do what? Mid equals to start plus end divide by 2. Again it will check middle element, right? This is a loop actually, okay? But what if the element not present? For that condition you have to write if your bits, if अगर देखो जब हमारा element ही present नहीं है, that means your what? That means start become what? Greater than your what? End. It is possible that if the element is present, is it possible that your start will become greater than your end? No, never. Okay. But if the element not present, okay, then it will happen. Okay. So you can write not found. The element not found you can write. Okay. Now let's run this code. So it will ask, okay, so I is not I. We don't need to write I here. We have to write here mid. Sorry. Okay. We have to write here mid. So here we will write enter number of elements. I am writing enter number of elements as suppose 8. Okay. I am writing n values as 10, 20, 30, 40, 50, 60, 70, 80. Okay. We have to write in a order actually. Okay. We have to make our array in a sort way. Okay. Now enter number of enter the element you want to search. I want to search suppose 50. Okay. I want to search suppose 50. Then it will say element found at index. So we have to write here percentage %d also. Okay. Here just write down percentage %d. Okay, now again we have to write. Okay, now we have to write 50. If I'm writing, then index value is 4. How? 0, 1, 2, 3, and 4. But if you are writing position, suppose, no? If you are writing position, okay? So you can write here, not index, but here you can write position, then mid plus 1. Okay, now do it again. So I'm writing 8 elements, 10, 20, 30, 40, 50, 60, 70, 80. Okay, 50 element I want to find. So position now become 5. Okay, so accordingly you have to write yourself. Okay, I hope you got this answer. How your binary search is working. I am now saying if I'm having 5 elements like this. Okay, all right. So I want to find 90. So 90 is not present now. So it will say what? Not found. Okay, I hope you got this concept. This is a binary search. If you have any query, you can write in a comment box. Okay. So this is simple one. That's a binary search that you are finding a key, right? It start from 0. Obviously, index start from 0. End will end minus 1. Middle you have to find inside it. Okay. Sometimes you do what? Middle you are doing. You are doing here. No, you are not writing here. You are writing before after this. Before your while. Okay. So this is also okay. But at the end you have to write here also. No, one more time. One more time you have to write here. So that is also okay. But why to write 2 times? So you can write in this way as well as this way. That's on you. Okay. So this is a binary search. Let's now talk about the algorithm of it. How we can write the algorithm of it. This is a simple algorithm. So we have to start from, our program, right? We have to start from the number of elements. So you have to write number of elements, right? We have to read the array, okay? Array index will start from 0 and will go to n minus 1, okay? You have to read the key value which you want to search. I have written here low equals to high equals to 0. Okay, high equals to n minus 1. You can write your way. First, sometimes I have seen that students writing first and last. So first and last you can also write accordingly. Na? LB and UB you can also write. LB is for lower bound and UB is for your lower bound. That's a only variable name, nothing else. It don't change anything. Okay, it will not change anything. So you can you can write anything. Okay, so now low is 0, high is n minus 1. You are searching while if your low is obviously smaller than and equal to, it can be equal to your high. Okay, so you have to repeat, calculate the middle value, low plus high divide by 2. Okay, and then search for your a mid and equals to your key. If it is okay, then that means element found at position, any position mid plus 1, and go to the step 8. Step 8 is stop. When you have already find the element, then you can break out. Okay, now but if the element is not in a middle position, then you have to check key is smaller than your a mid or not. If it is smaller then you have to change your high as mid minus 1. Okay, else you have to set low equals to mid plus 1. All right, so if your so this is how we can do it. Okay, so these steps you have to repeat. That's why we are writing in a ABC step. Okay, now if your low become greater than high, okay, then element that means not present in your array. Okay, so this is a very simple binary search algorithm. You can write step by step. Okay, so I think this video finds that very helpful basic concept of binary search. Okay, in a previous video I have already uploaded a linear search, so you can check out. So now in the next video, okay, so we will break down time complexity and space complexity of linear search and binary search also. Okay, so I will do step by step and it will be very easy. Okay, and you will understand it. Okay, all right. So we will see that complexity as well, and we will find out how it's going on, like how we can find the complexity as well. So if this video helped you, right, to get the concept, so please like, share, and subscribe to the channel. Your support really motivates me to create more code-oriented content. All right. Thank you so much.